I promised to help with 2 problems tonight on the homework, so here's the second installment of Mr. Rainier Helps Us with our homework. I'm going to talk next about problem 41 from section 2.5. Now problem 41 says, for what value of the constant c is the function f continuous on the interval from negative infinity to infinity? And again, we have one of our friendly piecewise defined functions here. This time f of x is equal to cx squared plus 2x for all x is less than 2, and x cubed minus cx for all values of x greater than or equal to 2. Now, both of those piecewise defined functions are polynomials. Cx squared plus 2x, a polynomial. X cubed minus cx, a polynomial, assuming c is a real number, and we're told in the problem that it is. So those are both polynomials. Well, we know from theorems that polynomials are continuous on their domains. And of course, the domain of a polynomial is all real numbers. So each of those pieces are continuous everywhere on their domains. That means between negative infinity and 2, the first polynomial is continuous by theorem, and between 2 and positive infinity, the second polynomial is continuous by theorem. So the only place we could potentially have any kind of trouble at all is at x equals 2. So what are we going to do? Well, we're going to do the same thing we did in problem 37. We're going to test to see if the function can be made to be continuous at x equals 2. Going back to our simple definition, that means the pencil can draw the graph without being lifted from the paper, or the limit from the left has to equal the limit from the right, and it has to be defined. Well, they're polynomials, so they're defined automatically, so we're really testing to see if the limit from the left equals the limit from the right. Well, from below, or from the left, we would be dealing with cx squared plus 2x. Now remember, we're trying to find c, and we know that that's the limit as x approaches 2. So we're going to plug the 2 in for the x squared and the 2 times x. If we do that, we're left with 4c plus 4. Now, we're going to take the limit from above, or the limit from the right. There, we're going to have to use the bottom portion of the piecewise defined function, x cubed minus cx. Again, we're testing at x equals 2 because we're taking the limit as x approaches 2 from above. So we're again going to let x be 2. Now that's going to give us 8 minus 2c. Now, to force this function to be continuous, we would want those two polynomials to agree or to meet or to touch at x equals 2. Well, we have two equations. The first one gave us 4c plus 4. The second one gave us 8 minus 2c. Set those equal to each other. Move the 2c to the left. We get 6c. Move the 4 to the right. We get 4. 6c equals 4. Divide both sides by 6. We get c equals 2/3. So that piecewise defined function is continuous at x equals 2 as long as c equals 2/3. There you go, installment number 2 of Mr. Rainier Helps You with your homework. Hope that helped. Have a good night.